In this video I'm going to show you how to take aerial photos for OpenAerialMap. OpenAerialMap is a crowdsourced collection of aerial photos with open licenses. This means the images are available for personal and business use. You can also trace them in OpenStreetMap. Another advantage is that images on this platform often have a higher resolution than commercial aerial photos. This CNET article talks about some of the common resolutions and the detail you can expect from each of them. Many of the pictures on OpenAerialMap are taken with a drone, and as you might expect, pictures from a drone are going to be clearer than pictures from a satellite. Satellite image resolution is also limited by law in the US to 25 centimeters per pixel, but there's no legal limit to the resolution you can capture with the drone. In fact, you can easily go as high as 1 centimeter per pixel with a drone, which is good enough to read utility labels on the road and political signs. I'm going to demonstrate that right now. So, these are two pictures that I took, and if you zoom in, you can read the natural gas markings. And if you zoom in here, you can read this political sign that says Smith Norrell. To begin the process, you need to choose an area to capture. Look at the area on Google or Bing Maps before visiting it, if possible, to get an idea of what the area is like. So, this is Bing Maps in JOSM. So this is the approximate area that I'd like to capture today. So right around here. You're going to be flying a back and forth pattern like the head in an inkjet printer. So we're going to be flying like this. Before you leave, make sure your drone and controller are charged, and make sure the drone has a memory card with a few gigabytes of free space. So this is the center of the area that I plan to fly. I've got the drone. You can see that I took the cover off of the camera, and I also made sure to put in a memory card. And here's the controller. So we're going to turn it on. We're going to turn on the controller first. And now we turn on the drone. So, to start flying, we push the two, we hold it up where we want it to start. Part of the reason we want to start somewhere, like one of the things that you have to think about is if it runs out of battery, it's going to return to wherever it started from. And you have to be careful that that's not too close to something that it could get caught in, like a tree. Another thing is, since we can only move about 50 meters in every direction, we want to find the center of the area we're going to fly, and that way we can reach the edges of it. Because if we start at an edge, we won't be able to reach the other edge. So I'm going to hold the drone, and I'm going to do the sticks. You move them like this. Alright. So now, we just get it to fly as high as it can go. Oh, one more thing. You have to move the wheel like this. So you move the wheel to the left, and that gets the camera to point straight down. Then you push this stick like this to get it to go up. And I'm gonna be holding the wheel like this and holding this stick up the whole time. So let me turn the camera so you can watch it go up. When it starts to make a different sound, that means it's gotten to the max height that it's going to do without a smartphone. So now it's at that height. So we're going to move it to the right to start flying the rows. Let me see if I can find it. It's extremely bright right now. Alright, I believe it's in view. Yeah, there it is. So I'm gonna move the camera over here to show you how the rows are done. Alright, I don't know if the drone is in view since it's so bright, but I'm gonna try to get it in view. So, let me see. We're gonna start here. Let's see if that's in view. Alright, so I'm gonna fly a row here, and then we're going to move to the side and fly the next one. So to take pictures, you push the button on the right here. So I'm going to take the first picture. Now I'm going to move it back a little and take the second one. And then a little more. And then a little more. Let's see if I can keep it in view. So now, to go to the next row, I'm going to move this one in that direction, and the drone, if it's visible, can be seen at a slightly offset position. So now I'm going to take another picture, and then we're going to keep going and do the next row. Okay, now you can get a better view of how the drone is going to move as I move to the next row. So I'm going to move it a little bit in that direction, and that should be good. Then I take a picture, and then I start taking more pictures.
Now that you captured the images, it's time to turn them into an orthophoto. We can't just concatenate the pictures together because everything that's not in the center is going to have different perspective depending on where the picture was taken. For example, if you take a picture directly over a building, then you'll only see the roof. But if you take a picture beside a building, then you'll see the roof and the side of the building. An orthophoto is a photo with orthographic projection, which means every part will look like it would if you were directly above it. To do this, we will use a free open source program called OpenDroneMap. You need a powerful and reasonably recent computer to do this. I'll be using a Dell Optiplex 7040 with an Intel Core i5-6600 and 64 gigabytes of RAM. I was able to get it for $529.17. I've also had success with an older Core i5 and 12 gigabytes of RAM. I'll be using Docker on Windows 8.1. Docker lets you run containers in Oracle VirtualBox virtual machines. I set my Docker VM to use 32 gigabytes of RAM and all 4 CPUs. You can change those settings in VirtualBox. You can find the command line options in the video description. I'm going to copy and paste it and add the name of the dataset to the end. Now all we have to do is press enter and wait. This should take about 2 hours. By the way, you may have noticed that I'm not using the fast orthophoto flag. This option skips a few steps and speeds up the process by anywhere from 30 minutes to 2 hours, but drastically lowers the quality, so you do not want to use it. Alright, so the process just finished. Let's see what the orthophoto looks like. That looks really good. This looks much better than the last one I took of this area. So it took about 3 hours to process the images. Average ground sampling distance is 1 centimeter. So that means we have a resolution of 1 centimeter per pixel. Now it's time to georeference it. So we're going to open QGIS. We don't need this anymore, but we'll just minimize it. So let's drag this into QGIS. And then let's add Bing Maps so we can georeference it. Okay, so as you can see, it's pretty close. It's pretty close to being exactly right. So now we just have to drag the file into the georeferencer and start adding points. So let's use the corner of this building as the first one. We're going to uncheck this and click right about here. Okay, now maybe a corner of this building. Let's see if we can use that. I think we can. Good. So we're going to use this corner of this building. We're going to click there and click from map canvas, and then we're just going to click right here. We need at least 3, but 5 is a good amount as well. So 3 to 5, maybe 3 to 7, but you don't want any more or any less because it's just going to look bad. What else is sharp enough for us to pick? Maybe one of the ends of these white lines. So how about the white line, like the second white line from the yellow part. So right here. Let's see about using that. Alright, we have 3. Let's see how that looks. So we're going to click the play button, and it says we have to set the transformation type. So, oh, that's annoying. OK is below the taskbar. So we're going to do LZW. It doesn't, the compression doesn't really matter. These are lossless compression modes, and we're gonna convert it to JPEG at the end anyway. Resampling method Lanczos. I believe that's going to give us the highest quality. And then thin plate spline. So these are some transformation types you can choose. I always use thin plate spline. Let's see if we can press enter to make this work. So enter. Okay, good, it worked. Normally my screen resolution isn't that low. Now we're going to click the play button again, and it's going to process it. Once it's done, we're going to have another file here called ODM orthophoto modified. Oh, there it is. And we're going to drag that into QGIS and see if it's aligned well enough. This looks quite good. Maybe we can add one more, because you see there's this white thing on top of the building, and you can see it in the Bing map picture. So perhaps we can use that as a fourth point. Alright, let's delete this. Actually, no. Let's leave it so we can see if it looks any better. Let's run this again. So, using a fourth point did change it a little. Let's see how it looks compared to Bing Maps. I think that's pretty good. We're probably done. Yeah, this looks really accurate. So, let's see. Should we crop it? This edge doesn't look that good, but I don't know that it's bad enough to warrant cropping that out. This is an abandoned house, I believe, but it looks alright. No, wait, this is the abandoned house. This might be a shed behind it. This doesn't look too bad. I think we can just upload it as is. So let's do that. We're going to need to go to the location. We're going to need to go to the folder where QGIS is installed and get GDAL translate. So we're going to open a command prompt and do this. We're going to drag it into the command prompt. We're going to do CO compress equals JPEG, and then we're going to drag the file. Oh wait, we need to save our points just in case we want to process this again later. So save GCP points as, and it'll open a dialog at the same location where the image is. So we're just going to save this and we're going to close it. Now that we know we can get back to that if we want, we can compress this with JPEG. So I'm just going to add underscore JPEG and we're going to compress it. Okay, it's done. So the original file, or the modified file, is 233 megabytes. And this is 34.2 megabytes. So now I'm going to upload it to designingonajuicycup.com and then get the URL. So the file just finished uploading. Let's get the URL. Now we can upload it to OpenAerialMap. So if you were doing this for the first time, you would click URL and paste it there. Today's date from midnight to just before midnight is the default. If you know exactly when you took this, then you can make it more precise. I know that I stopped before 159, so I'm going to put 159 there. UAV, you want to choose UAV and not. I think it defaults to satellite. So just make sure it's set to UAV, and then the title. So what is this? This is the, let's see, Main Street Abandoned Feed Store, Part 1. Alright, so Abandoned Feed Store. And then today's date, July 14th, Part 1. Okay. Provider, you can use your name or a company name. License, Creative Commons, no commercial, and Creative Commons share alike. I'm just going to use the default, Creative Commons. And then click Submit. It'll give you a link, and it'll also send an email. It'll send a confirmation email, so you might hear my phone make a noise. That was my phone. Let's see. I'll read the email to you. It says, let's see. The email says, OAM uploader, imagery upload submitted. Your upload has been successfully submitted and is now being processed. You can check on the status of the upload at this really long URL. So, it says pending. It only takes a few minutes, but it'll start populating this section with the steps. So it has to download a copy and then turn it into tiles. Status finished, so it's done. I don't know why view image doesn't work, but let's go to the end. Here it is. So it looks pretty good. It says resolution 1 centimeter, which is what we were trying to do. So yeah, this looks really good. And that's how you upload an image to OpenAerialMap. Now let's add it to JOSM. So we click this, and it copies the TMS URL to the clipboard. Then we go into JOSM, we go to Preferences, and we click Imagery. You can see I've used one already, so we're going to delete it. We're going to click TMS, we're going to paste it, and we're just going to get rid of one character and add it again, because for some reason it doesn't work unless you do that. And we're going to name this Abandoned Feed Store Part 1 and click OK. Now if we go to Imagery, we can click it and we have it in JOSM and we can trace it.